So we'll be talking about C# is the future. And there's been a lot of changes over the years to C# as a programming language, and especially in regards to what we can do with it and how it helps us to write better applications. I'm Filip Ekberg. I'm a senior software engineer at a place called Invoice2Go. If you have an Android or iOS phone, you should definitely try our app. It's one of the best ones in the stores. Other than that, I wrote a book called C# Smorgasbord, and I might give out a few if you tweet about this talk as well. All right, enough about me. C# through time has had a lot of interesting changes. We've seen it going from something looking like Java and C++ into being something that more and more people kind of adapt in their applications or in their software development life cycles. So looking at the evolution of C#, we see that C# started off as an imperative programming language. And then over the years, we got influences from declarative programming languages, and we got things from functional programming languages like F# and Scala. A lot of the language features added to C# is inspired by things like F#. So anyone here remembers using C# 1.0? Coetzee, 1, 2? Yeah, so a lot happened after C# 1 was released. It kind of started out as looking like Java or C++, but having a garbage collector and being managed made a lot of difference. So with the first language revision, we got a lot of interesting features. One of the most used ones, I'd say, is generics. It's interesting to see how other programming languages still don't have generics. Looking at Java, they just recently got generics, and somehow, after waiting so long to implement it, they still got it kind of wrong. We also got partial types, anonymous methods, iterators, nullable types, getters and setters with separate accessibility and static classes, and a few more things. So if you thought that C# 1.0 was the best programming language yet, we could still add a lot more features that made a lot of sense to us as developers. And then came C# 3, which introduces a heap load of features again. So if we were using C# 2 and we're happy about having more features than Java developers or PHP developers, we got even more features that help us write better applications. I remember the first one here when I started to use implicitly typed local variables. People started telling me that you shouldn't use that because now you don't have static typing anymore, which was kind of silly because that's not how it works. We didn't get the dynamic keyword until later on. And we also got object and collection initializers. We got auto properties, which are excellent, which I think every one of us uses all the time. We've got anonymous types, extension methods, query expressions, lambda expressions, and expression trees. And all of these final things here that I mentioned, they all kind of worked up to becoming LINQ, language integrated queries, which gave this functional approach to C#. So coming from F# or Scala, you get this functional approach to the language, which makes it a lot more cleaner and fluent to write. Then came C#. And looking at how C# changes from how C# 3 changed, we see that there's a lot of less features. The amount of features added to the programming language isn't really as substantial as we saw before. Now, implementing dynamic binding and being able to do dynamic programming in C#, which is a statically typed programming language, doing that is not really simple. Implementing that on a maybe 8 to 10-year-old code base written in C++, unmanaged code, that's not an easy job to do. And we got named and optional parameters, generic encode and contravariants, and a few more smaller things. So thinking about the amount of features being added here, something must have happened at Microsoft at this point. Or they just felt like C# is now a complete language and there's nothing more to add to it. And it kind of becomes obvious when we talk about C# 5, which introduces asynchronous methods and coloring for attributes. Now again, adding something like asynchronous programming to a programming language that is 10+ years old, that's not an easy task to complete. But still, we have a lot less features compared to C# 2 and 3. So what really happened at Microsoft here? Why did they stop adding more awesome features to C#? Well, looking at what the future of C# is and what's going to happen, we're starting fresh with a new compiler. So Microsoft introduces something called the .NET Compiler Platform, which kind of encapsulates both C# and VB. It's also codenamed Roslyn, and if you followed Roslyn along the years, I think they announced it in 2008 or 2009. So it's been worked on quite some time. Visual Studio 2015 will be the first IDE to use that out of the box, which is quite exciting. So they decided to rewrite the compiler, and kind of anyone that's worked with a maybe 2-year plus code base know that it's time to rewrite your code sometime. And even if it's kind of this break point where, well, it might be worth adding more features to an old code base, or it might be worth rewriting from scratch, it might be hard to find that point in time. But after maybe 10 years, Microsoft felt like, well, after the 10-year mark, we need to release a new compiler. And the new compilers are totally written in managed programming languages, which is C#. So they're using the old C# compiler to compile the new compiler, which will compile new C#, which is pretty cool. What this means is that Microsoft makes it easier for themselves to extend the programming language. They've learned from the mistakes and all the paths taken to implement a complete language and implement this compiler. So they learned how to make it more extensible and being able to add more features. What's also interesting here is that writing this compiler means that they could either say, like, let's fix all the bugs in C#. Let's fix all the gotchas that people found out there. That would break backwards compatibility. So what they have to do is that they have to implement all the bugs from the old compiler when they rewrite it in the new one. So looking at what we kind of get from the future now is that we're going to go into an era where we trust the compiler much more. So we're going to trust the implementations of certain language features and trust that Microsoft implemented these for us. Which also means that we need to understand the complexity behind using certain keywords. What it means is that it lets us be a lot less verbose. We can use syntactic sugar like the dynamic keyword or the var keyword or async and await and kind of generate a lot of code behind the scenes. Meanwhile, we just have this linear and nice code base that we can easily maintain. But it also means that our code might become more fragile, so we might need to have to think about what's really going on behind the scenes. Now, the new compilers are totally open source, and Microsoft is really committed to doing open source work. It doesn't mean that they sit inside Microsoft in a black box, and after 2 months, they just release new code on GitHub. It means that they're actually doing all the work in open. So they let us join the conversation about talking about new language features. They let us see the issues and bugs in the compiler that they're currently implementing. And we see this across different projects as well, like ASP.NET. They're doing that totally in the open as well. And the .NET framework on CoreFX is totally rewritten, and that's also going to be open source. Yes?
Phil, I'd just like to make a little observation. This Roslyn was originally hoped to come out in Visual Studio 2010, and then they decided to ship it in 2012, Visual Studio 2012, but then they finally decided Visual Studio 2013, but it wasn't quite stable enough. So it's been in the making for a long time.
Yeah, so as I said, they announced this in 2008 or 2009 at Mix, I think, and they hope to release that in 2010 or 2012, but they probably noticed that along the way it takes a long time to implement a compiler. They had some really smart people working on this as well. It's really amazing. So C#6 is upon us, and for those of you that have followed this kind of evolution of C# over the year, maybe, I've done a few different talks on C#6 before, and it's interesting how each talk is totally different because they've canceled features and they've added more stuff and they've changed features. So all of these things that are coming in C#6 is kind of coming to a final state. So we're close to the RTM of Visual Studio 2015, which will be on the 29th of July. And that's the first IDE that will have C# as a main programming language, as well as using the Roslyn compiler in the backend. So I'd like to go through a few of these features that are being added to C#6 that are now confirmed to be added in Visual Studio 2015 and if you're doing C#6. The first one is called using statements for static members. It basically means that we have this code block here, and the only thing that's really irritating here is that if I want to do more console writeline or use more of the math operations, I'd have to do console.writeline everywhere. So instead of doing that, we can introduce this nice new using statement that we see on the top here, saying using static methods or statics from this system.console type, which essentially means that when the compiler compiles our application, it will look for writeline and sin in the scope of this compilation, which means that it'll know that it can look inside system.console, it can look in system.math, and if we have this method written inside our class, it'll use that instead because it's closer. So it'll use kind of the same principles and logics that we've seen before for other overrides and stuff like that. It's a small feature, but the idea is to be less verbose and add these types of features that makes it a lot more easier for us to develop our applications. So we can kind of think of this like a poor man's IOC, I guess, because we can just add a lot of using statements like this on the top and then just get a lot of static methods inside our classes. So now you might think to yourself, what happens if we, for instance, change system.console to system.debugging, which means that we could use debugger.writeline instead. That means that it would simply use that instead, which is quite excellent. Another example that I like to take up is when we do enumerable.range. So I do system.link.enumerable.range a lot, especially if you want to pre-generate like a set of, if you have a people class and you want to generate 10 peoples, it's nice to just do range 0 to 10 dot select new person, just for testing purposes. And having this shorthand like this here and skipping to do enumerable.range everywhere just saves a few characters. And since people argue about spaces and tabs, why not just make it simpler and skip a whole word? We're also getting something called auto property initializers. So auto properties are really powerful, especially if you come from a different programming language that don't do auto properties at all. You really start appreciating how the auto properties work. So auto property initializers means that if I want to set my name here to a start value, when I create the person class or an instance of my person class, I want to set this to an initial value. Now the way that I have to do that before is by introducing a constructor for this person class, which isn't really that much code, but it's just noise added to my class. So instead what we can do here is that I can say my auto property is equal to the value that I want to specify it with. And also notice here that I don't specify the setter for this. That means that we're now introducing a true read-only auto property. And we can do the same from the constructor. So if we have a getter-only auto property, we no longer have to manually set the backing field to the value that we want to initialize that with. And this compiles down to something looking like this here. So we see that it, in fact, creates this read-only backing field. And because I used a constant, it doesn't introduce the constructor. So the compiler is kind of smart enough to know what kind of code to generate. So again, we trust the compiler to hide a bit of complexity for us. And this simple example here, it might not seem much, but when our classes starts to grow, it's kind of nice to avoid repeating ourselves. And for those of you that have done async and await and asynchronous programming in .NET, you'll really appreciate having awaits inside catch and finally blocks. So we're now able to say that I want to await something inside my finally block, for instance. And what this means is that we could simply clean up resources, for instance. We could add something to the database asynchronously and wait for that inside the catch or finally block. One of my favorite features is probably the null conditional operators. It's been talked about like null propagation or the Elvis operator over this past 2 years. And it's a really nice feature added to the programming language. The problem, or the original problem, is that C# allows us to use nulls, which is essentially the root to all evil, because you'll have a null reference exception. Like anyone in here, I bet, have had a null reference exception. So the idea of introducing null conditional operators is to make it easier for us to determine if something is null or not. So let's take a look at this class here, for instance. I have my person class, which introduces another class called address. If I initialize this person here, called Filip, and I don't set the address, that means that if we do something like this here, it's going to say, well, the address is in fact null, so we're going to say no address. But if I initialize the address property, we can go ahead and get the address line 1. It's not a lot of code added here, but we can make this a lot more prettier by introducing a null conditional operator. And there's also a bug in this code here what happens if Filip here is actually passed in through a method, and Filip is null? That means that we will get a null reference exception by doing Filip.address, which is essentially a problem. We might think that nulls never occur in our applications, but they always do. So what we can do to fix this is introducing these Elvis operators. They're called the null conditional operators. And we basically say, if Filip is not null, go ahead and give me the address. If address is not null, go ahead and give me the address line 1. And if any of these here evaluates to null, the entire expression is null. So we can use the double question marks at the end and say no address. Yes?
Question on that. The Elvis operator doesn't have to be used all the way down, does it? It can be used at the first level, and then that logic trickles down through.
So you're asking if it would be enough to just do Filip question mark and that would just work?
Yes.
So I don't think so, because if address here was null, I don't think it would check that as well.
Yeah, okay.
We could give that a shot and see what happens.
Yeah, cool. No, I remember. Oh, yeah, okay.
Now we can give it a shot and see what happens, because that's interesting, because that means that you wouldn't have to do question marks everywhere. So let's try it. I have a WPF application here, so we can do this class called person. Can everyone at the back see the text? Perfect. So let's do property address. All right. So now, if I introduce this variable up here, we hopefully would get a null reference exception. So if I do person dot address line 1, let's try that first and see that this works. Just going to run this and make sure that it doesn't crash. And it crashes because address is in fact null. So that doesn't check the rest of the operations. So this also means here that when I do these Elvis operators, if any of these here, if person is null, address is null, or address line 1 would be null, this entire thing would be like a null, just return null statements. Right? Yep. Sorry, can you repeat that? So your question is, if you have, in this case here, it's checking if Filip is null. Are you asking if it's going to go ahead and check if address is null as well? No, it's not. So we'll see this on the second line here, or the second slide. Or I'll have a snippet where it shows what this compiles down to. So in this case here, we have an array of people, and I'm initializing the first person. And sometimes we would get nulls in our list as well. And just as we could use the null conditional operator when passing or accessing a property, we can do the same thing in here if it's an array. And even if we want to use an indexer and say, hey, is this array here null? We can say, if the array is not null, go ahead and give me the first index. And if the first index is not null, go ahead and give me this property. So this compiles down to something looking like this here. It could be optimized by the compiler when we were at the RTM version. But basically, you see here, it first checks if the people is null. If that's not null, go ahead and check the first index. So it doesn't do any unnecessary checks. My second favorite feature is probably string interpolation. I've been seeing myself using this quite a lot, as well as the null conditional operators. It's probably the most used features in my solutions today. So simply enough, we're introducing this $sign in start of a string here. And it's like the @ sign. When you add that to a string in the start, it lets you do multi-line strings. So it has a special meaning to the string, which in this case says, whenever you see these curly brackets or these curly braces, go ahead and enable me to access properties and methods in my scope. So in this case here, This is simply going to be a string format in the end, but it allows me to access properties inline in my string like this. So looking at what this compiles down to, we have this simple string.format. But writing that string.format, like I know a lot of us have done plenty of times, you kind of can get the order wrong, right? So you have to remember, do I need to add the height first or the width first? Like that gets a bit messy.
Particularly if you change the order of the string around, right?
Yep. Yeah, so if you change something in the string or you change any values anywhere and you need to switch that around, it's always going to end up being wrong. And it also works with the built-in formatting for strings. But meaning that this part here is actually visible to the IntelliSense, that means that it can give us IntelliSense for the formatting itself. So since we say this here is a code block, Visual Studio can go ahead and analyze that as like a property, or if we do like a method call or anything on the property that we're accessing. So in this case here, I'm simply saying the age field should be printed out with 5 digits. And when I run this here, it simply says, hello there, my age is, or hello there, I'm 00028 years old. And looking at what this compiles down to, we see that it's a bit messy, like having to write that yourself compared to using the string interpolation. Like it's just a lot easier. So again, we see here that Microsoft introduces these language features in C# to make it easier for us to express ourselves in our programming language and make it easier for us to avoid having these types of problems. Now, next up, we have dictionary initializers. We've had dictionary initializers for a long time, but now they're introducing support to make it a bit easier to initialize our dictionaries. If you try to initialize a dictionary on one line before, it means that each line needs to start with 2 curly brackets, and then magically the first one that you specify inside the curly brackets, that's the key. In this case, it gets a bit more explicit, saying, hey, the key is Philip. I'm setting that to a new person. And as well as I can use this with integers as well. So here I'm saying that in my dictionary, the answer 42, that's the answer to the life, universe, and everything. Next up, we have something called expression-bodied members. Now, expression-bodied members allows us to write a bit less code and use expressions to define our methods instead. So in this case here, I'm actually using 2 features from C#6. I'm using both the expression-bodied member together with a string interpolation. So I have this simple rectangle class. I have 2 properties, and I simply want the toString method to write out my width is width and my height is height. Previously, you'd had to do the method body, you had to return, you'd have to put this together with string.format, which would just be a few more characters, but this is a lot more cleaner. Now finally, or almost finally, this is the second final feature, is the Nameof operator. It's a small one, and it might seem quite unnecessary. So in this case here, I simply want to print out the name of my parameter. So I'm saying my parameter, the name is Nameof_args, which simply, as you see here, it prints out the value args. So I'm writing the value that I want to print out to the console, but what's the benefit of doing this? Well, if we check wherever my fields or my properties are used, we can see that we use these in strings as well. So it gives us visibility of where our properties are used. It gives us visibility of wherever we embed that in a string. And especially if you're refactoring a lot of code, that'll turn up here. So finally, we're getting exception filters. It's a simple way for us to express that we want to filter exceptions based on a certain criteria. So as you see here, I'm throwing a new exception. I'm setting the severity to a high value, and I'm saying, catch this custom exception whenever the exception severity is above 50. Now this compiles down to a simple, it's catching all the custom exceptions, and then it's internally having these 2 if statements, checking if it's above 50 or not. But I don't have to write that anymore. So it becomes a bit more explicit. So looking at these language features or these upgrades to C# side by side, we can definitely see that introducing the .NET compiler platform gave a lot of potential to the programming language. So we can for sure see that even if C# 4 and 5 didn't get as many language features, we really got a good bunch of features added to C#6. And we can see that the language lives on. We can see that Microsoft is totally invested in making this the best programming language out there. So again, we've got using statements for static members, auto property initializers, awaits inside catch and finally blocks, null conditional operators, string interpolation, dictionary initializers, expression bodied members, exception filters, and the Nameof operator. That's just a lot of features added at once to this programming language. But that's not all that were added from the start. We're talking about a lot of features being added to C#. We have a huge bunch of features that were actually withdrawn from the programming language. And the reason for that is that they just didn't have time to add tooling support in Visual Studio. As Adam mentioned before, they wanted to release the new compilers back in 2010. Now, if they want to add this amount of features and giving tooling support in Visual Studio for all that, they need to prioritize. Like anyone working in an agile environment, we need to reprioritize and add things to the backlog and take care of that when we have time. So the withdrawn features is binary literals and digit separators. Probably not the most commonly used feature, but if you're a game developer or working with graphics on the back end, this will probably be handy. They wanted to make event initializers a bit better, to allow us to use events inside the object initializations. They wanted to do field targets on auto properties, which in this case would mean that the backing field for the property age would be non-serializable. Now, I'm a bit bummed that they excluded semicolon operators. What this means here, it's kind of a new way of seeing this right-hand side. So the entire expression on the right hand is kind of evaluated as one big method or one big expression. So we're first retrieving the value x from the method foo, and then we're printing out the value x, and we're returning x in square. But that entire thing will just be one expression, and y will have the result of x in square. I think this is a really handy feature, especially when you just want to print something out or you want to debug something. Just makes it a whole lot easier. But that's not all. They also removed primary constructors, which is also a big bummer. Primary constructors meant that we could, on our class declaration, say that these are the two minimum fields that we need to specify when creating this object. And we could even use them for field initialization. We could use them for auto property initializers. And what's interesting here is that they have all these features implemented in Roslyn, but it's probably just sitting on a different branch in GitHub. If you want to work with two-dimensional arrays of data, they wanted to allow us to do params with INumerable, which is also a withdrawn feature. Finally, I had a friend maybe 6-7 years ago who asked me, why is there no way for me to express on one line when there's an out parameter to say that just generate this field or this variable whenever the out parameter is actually present? So they wanted to introduce declaration expressions, which means that in this case here, I'm saying calculate the age based on my birth year and out that as an age parameter. And they wanted to introduce that we can say out var age, which will introduce this variable for us. It saves us one line of code, but that's not really a lot. It's just a nice feature to have on one line, because that's really what it is. So why are we talking and caring about the withdrawn features? Well, it indicates that the language is evolving and that it's an ongoing work. And we can see that it's kind of an agile approach to it, and they're working with this as a way that they want to introduce one feature. If they don't have time for it, they'll just do it the next time, because there's no hurry unless they get it fully supported in Visual Studio. And it also shows that there's no promise until it RTMs. So until July 29th, or 20th, I cannot promise that these features that I've talked about will show up in Visual Studio 2015, but they sure are present in the RC versions. And interestingly enough, withdrawn features does not mean that they will never turn up. It doesn't mean that it's features that will never show up in the next version of C#. And we'll see that now when we talk about C#7. Yes? You're asking if you can compile old C# code with the new C# compilers. So the new compiler is totally backwards compatible. They had to re-implement all the bugs in the old compiler. So it will let you compile C# 1, 2, 3, and 4, and 5, and 6. Yeah. So you're asking if you use one of the withdrawn features, what happens when you compile with the RTM version? Well, it breaks. That's the simple answer. Because there's no support in the compiler to use these withdrawn features. They've taken that out of the compiler. And if you're on a RC version or a beta version of the compiler, you're just helping Microsoft to know if the feature is highly used and if it's something that I need to put a lot of focus on. So until it actually RTMs, there's no promise that it will show up in the language. But as we'll see with C#7, they are introducing a few of these features again. But since they didn't do full work on them and didn't implement the features in their entirety, like there's still a lot of changes going on. So you're asking if you have an old code base today, if you can go onto the new compiler and you're afraid that they're withdrawing features? Yeah. Well, they're not taking out any features from what C#5 looked like. They're not taking out any features from a previously stable programming language version.
Well, that's what I thought you meant initially as well. That when you said withdrawn features, these are things they deprecated from old versions of the framework. That's not the case.
Okay, so yeah. So Kotsu mentioned that it's not deprecated features in the programming language. It's withdrawn from the work of C#6. So they introduced a lot of features when they started working with C#6, and that's features that they put on a waiting list.
So another way to look at it is those features were in the beta 1 of Visual Studio 2015. And they were all there, they're all working, but they need more testing. And people were going on saying which features they wanted, and there was lots that had really low votes. And Microsoft have limited resources, so they didn't give them to you now, but you'll get them in updates, because they're there.
But to be clear, you haven't lost them from your previous code, unless you built your previous code on beta 1 of Visual Studio 2015.
Yes.
If you built your previous code on anything before that, soon. You're okay.
Yes, so the features are actually coming soon, which is what the next part is about. So in C#7, they're introducing a few features. So they're starting off with talking about a highly liked amount of features, and one of them is being tuples. We've had tuples in C# before, but they're making tuples a lot better. And they're allowing us to specify multiple return types. So in this case here, I have a method called calculate. It takes on a list of numbers, and then I want to return 2 values. And lazy as a developer I am, I don't want to set up a class. I don't want to return an anonymous type. I don't want to use dynamic. So in this case here, I can simply say, I'm returning a tuple with these 2 values of sum and count. And when I use this later on, I can say, give me the result of this calculation from this range of numbers. And as you see in the right line here, I can even call those fields on that tuple. So I can use result.sum and result.count. Now this is a feature that they're talking about adding in C#7. It's an ongoing discussion. You have the link at the bottom. You can join the discussion on GitHub and talk to Microsoft and other involved people and see where the discussion is going and how that's going to look in the next version of C#. They also want to introduce pattern matching and record types. Is anyone here a functional programmer? No one? Anyone done any F#, sorry? One? So pattern matching is about allowing us to identify an expression and kind of what that matches to. That requires us to specify record types. And record types, they require us to specify primary constructors. So as we see from the withdrawn features in C#6, from the C#6 beta, we see that they're introducing this again. So in this case here, I'm introducing a record type, which is the sole purpose of a record type is to allow me to do maths on it. So I'm saying here, I have a public record class point. It has one X and Y property or field. And then I can, at the bottom here, I can say if a certain expression matches all the fields on a point, then I can use that in this scope. And pattern matching is really powerful. You can see yourself having like a big switch statement where you get an expression from somewhere, and then you match to wherever you want to run this. So if it's a point, for instance, if it has 4 points, if it's some other type. Right? You can also join this discussion where they talk about primary constructors and introducing pattern matching in C#. It's a highly liked feature, especially if you're coming from a functional programming language like F# or Scala. So there's a list of potential features that they want to add to C#7 as well. Interestingly enough, all of the features that I talked about being withdrawn from the C#6 specification are added to this bucket of features in C#7. Since they've already done work on most of them and added feature support in Roslyn, there's just no tooling support. There's no way they're going to throw away that code. They're just going to let that sit on a branch in GitHub. One thing they want to add is nullability tracking. So since C# allows us to have nulls, they want to allow us to track if a value is null or not. It's basically doing an if statement without the actual if word. So instead they call it check, and then you specify the parameter you want to check. And if you get into that scope that you're checking, you're not allowed inside that scope unless that is not null. It's basically just doing an if it's not null. They will allow us to do asynchronous streams, declaration expressions like we talked about in C#6, and binary literal separators also from the withdrawn features in C#6, and potentially a lot more. So there's a lot of ongoing talks about what kind of features to add to C#7. And you can join the discussion on all these different work list features. They have an entire list of things they want to implement, where they range things from this is the most liked features, this is the ones that we like to get into the language, but we don't know if we have time. This is the features that we might do if we have a lot of time left. So you can join the discussion there, and they talk about all these pattern matching and the declaration expressions and primary constructors. So it's really endless potential looking at what they can do with the new compiler, what they can do with C#6 and C#7. We can see that they're starting to discuss everything in the open. Microsoft is really changing the way that they work. From being like very silent and only disclosing things at conferences, they're now having open discussions on GitHub with other developers, getting feedback from everyone that are actually using the programming language. And one thing that I didn't talk about is the compiler APIs. So think of the Roslyn compiler being at your disposal as an API you can pull down from NuGet. So you can say, hey, I want to compile my own C# code, or I want to do C# scripting, for instance, which will probably show up in the future. You could write analyzers and refactoring plugins. Imagine that you start a new job. You pull down the source code for the project that you're working on, and together with the source code, it also introduces a lot of analyzers and refactoring plugins. It just installs that as a part of your project. That means that as you go on and learn the product, you also learn the coding standards of that project. It's going to make it easier for open source projects because they can specify their analyzers and refactoring rules and plugins, and you can kind of stay away from reading the contribution guidelines. You should, but yes, question. So you're asking if you can change the IL with the Roslyn compilers. So the way that the compiler works is that you can take the submission of a code file. You can point to a C# file or a string in your code. You can say compile this. The compiler takes that, puts that into memory, and that will let you analyze the structure of the code. So you kind of get a representation of the entire syntax tree in memory. So you're asking if you can work with it like PostSharp and other IL rewriters and do aspect-oriented programming. You can for sure do that with Roslyn. That's a really excellent approach for it as well. So what you do instead of doing IL rewriting, you can rewrite the syntax trees before they're actually compiled down to IL. Question? Yes, so you mentioned script.cs, which is built on Roslyn. Yes, so when they first announced Roslyn, or when they first released their first CTP, they also had scripting APIs, which allowed you to do C# and VB scripting. But they took that out of the compilers because it took a lot of time to implement that, and they wanted to focus on the features of the C#6 and 7 languages instead. But it's in the backlog in GitHub. They're talking about how to implement scripting in C# and how to make that a part of your daily experience. Because I remember when you first installed the first version of the Roslyn compilers maybe 2 years ago, you also got a C# interactive window, which it's basically like the F# interactive window where you can just write small code snippet and they evaluate like scripts. It's kind of a read, eval, print loop, which is quite excellent. So as we see here, C# really evolves and grows with each release. Even if Microsoft didn't focus on adding a lot of features to C# 4 and 5, that's probably because they worked on the new compilers and they wanted to make sure that soon enough we could release that compiler as a part of Visual Studio and give us a lot more language features. So what about F#, Java, PHP, Python, Ruby, Haskell, other programming languages? Aren't they also part of the future? Well, they're all taking notes from each other, right? So C# is being inspired by F#. We wouldn't have generics or async in C# if it wasn't for F#. We for sure wouldn't have language integrated queries and expression trees and all that if it weren't for F#. And looking at tuples and pattern matching and primary constructors, Microsoft is looking at other programming languages that implements those kind of features also. So C# is really here to stay, and looking at the jobs out there and how many jobs there are actually looking for C# developers, I don't see that changing anytime soon. We kind of saw a change in pace when iOS, Android, and all the mobile platform or the mobile era took over, but I can see a little trend changing now as well, that we do everything in one programming language, like C# and using Xamarin to target all the different platforms. No one might want to invest anymore in writing one app for one platform, but instead they're using things like C# or HTML and CSS for that. So as we see, C# is really here to stay. It is the future, and if you're not already doing C#, it's time to embrace that. Anyone using C# 6 or Visual Studio 2015? What are your favorite features? Sorry? Are your favorite features the null conditional operator? Yeah, mine too. Yours, Coatsy?
Yeah, I was going to say that as well. I do like the string, the embedded string.
Yeah, the string interpolation is really excellent. I think Miguel, who wrote Mono, he introduced that in Mono a long time ago. He wrote an addition to the Mono compiler to introduce string interpolation. But since it's not a part of this standard, it's no point in adding it to the Mono compiler, because then C# would look different if you compile that in Visual Studio and Mono. All right, thank you so much for listening to me. I hope you enjoy this, and I hope that you'll embrace C#.
Did you get all that? We'll take the SSW TV quiz and test your knowledge now.